What's up? This is Ryan Massey at MRH High School, and today we're going to add some vectors. When vectors are parallel, we get to use simple arithmetic. So in this particular case, with number 1, we place our vectors tip to tail. We want to know how long the resultant is. I simply do 280 plus 96 because these are in the same direction. You might be able to do that in your head and see that it's 376 nanometers, but feel free to use a calculator to check your work. And 280 plus 96 is in fact 376 nanometers. For problem 2, you can see that these are in the opposite direction, so we want to subtract, and the resultant vector will be to the left. You could do 52 minus 98 and see that you get a negative value, which indicates to the left. Or you can graphically notice that the piece that's left over once you subtract will be this one, which is the larger vector is pointed to the left, and just recognize that your answer will be to the left. Vertical works exactly the same way. We simply add when vectors are parallel and in the same direction, and we subtract when they're parallel in the opposite direction. So let's look at some cases that are a little bit more difficult. When you have perpendicular vectors, you get to use Pythagorean Theorem. So let's rearrange this a little bit. We add tip to tail, and we look for the resultant here. The resulting vector starts where we start and ends where we end, and we want to know the length of this vector, and we want to know the angle that it's of its direction. So first, let's think about Pythagorean theorem rearranged to solve for the hypotenuse, and that gives us the square root of 94 squared. Not 94 to the 94th power, that would be interesting. 94 squared plus 170 squared. And that gives us a hypotenuse of 194 meters. Okay, now to find the angle, let's take a look at this parallelogram here and ask ourselves, what is this angle right there? What angle does this resulting vector make with the x-axis? By symmetry, we know that this side is 170 and that this side is 94. So let's do a little bit of trigonometry here, right? We want to take, if we want to look at the y-axis, we would use sine. If we look at the x-axis, we would use cosine. So let's start with sine. And I'm going to switch to this calculator since it's easy to switch between radian and degree modes. We would do opposite over hypotenuse, which would be 94 divided by 194. And then we would take the inverse sine, which is second sine. That gives us an angle of 28.98 degrees, or rounded up 29 degrees. If we want to solve this with cosine, we would use the 170, which is the x side of our triangle, and we would do 170 divided by 194, which gives us a different decimal. But when I do the inverse cosine, I get that 29 degrees back, right? So whether you use sine or cosine, you're still going to get the correct answer. With these problems down here, they're also perpendicular, so you use the same approach. Now we're looking at some vectors that are not parallel and not perpendicular. So let's use a little bit of trigonometry to make them perpendicular or make them parallel. Let's clear out some of this. So we can focus on a single problem. Let's look at problem number 8. We have a 17.3 magnitude vector pointing at 45 degrees with respect to the x-axis, and we would be in the second quadrant here, right? So if you are referencing the angle with respect to the 0 degree angle in the first quadrant, you would go all the way to 90, and then 45 degrees more, this would be 135 degrees. Okay, well, let's split this into components so we can make this problem a lot easier on ourselves. Okay, and what we would want to do is create a parallelogram, not unlike what we did before. We can get rid of this guy for now. So we're starting to look at the components of this 17.3 meter per second vector. Right? Right. Let's move this guy for now and create a little box here for us to write on. If we want to find this side, what we would do is take the sine of 45 times the hypotenuse, because this side corresponds to the opposite of the angle, which is the y component of our vector. So we want to take 45 degrees and take the sine of it, which gives us 0.707 times 17.3, which is the hypotenuse, and it gives us a y component of 12.2. Now to find the x component, we're going to use cosine, because cosine corresponds to the adjacent side of the angle, which is our x component. So we want to take 45 degrees, and we want to take the cosine of it. For 45, you have some symmetry here, so you get the same value times the hypotenuse gives you the same result. So this side would be 12.2. Okay, now we have our x and y components. And now everything's parallel and perpendicular. So this x component is now parallel to this 6.8. I can add using arithmetic. And then I can simply recombine these guys together to get the total resultant. Geometrically, it would look like this. I've got my x components being added together, and I've got my y component adding here, and the resultant is going to look like this. And I would use the same methods I used before to add these vectors together and use Pythagorean Theorem to find the length of the hypotenuse. And that's not necessarily going to be 45 degrees. You would need to recalculate that as well. All right, thanks for listening, and enjoy your vectors.